So let's evaluate the integral using, again, trigonometric substitution. And in this case, I'm going to start with a right triangle. And note that we have the square root of 25 minus x squared. Okay, so of course if I could take the root of that, that's 5, and take the root of x squared, I get just x. So I'm going to throw in a theta over here as an angle, and the opposite to theta will be x, and my hypotenuse will be 5. And why am I doing this? Why on earth would I make such a triangle? Well, if I figure out the third side using Pythagoras, I will figure out that it measures the square root of 25 minus x squared. And why is that again? Well, because if I make question mark squared, question mark being this side, right, plus x squared, that's equal to 5 squared. That's of course Pythagoras. So if I want to isolate, that doesn't look like a 2. If I want to isolate the question mark, I get 25 minus x squared. If I root both sides, I get the square root of 25 minus x squared. All right? So, and that's going to help us quite a bit. And why is that? Well, now let's say I'm going to figure out what the sine of theta is. And remember SOHCAHTOA? By now in calculus you should remember this. And sine is opposite, which is x, over hypotenuse. And the hypotenuse is 5. So in this case, I'll just cross multiply this, so I get x is equal to sine of theta. And what I'll do, because we're essentially doing substitution here, I will take the derivative of both sides and end up with differentials on both sides. So we're going to get 5 cosine theta d theta if I derive this side. Don't forget the differential, because the derivative of sine theta is cos theta. And on this side, x, if we derive it, we just get 1. So that's just the differential dx. So right away, I can actually just plug this in for dx over there. So I get the integral of root 25 minus x squared times 5 cos theta d theta all over x squared. And we know that x is 5 times the sine of x. So if I square both sides, I get x squared equals 25 sine squared theta. So I can plug that in down below for x squared. So 25 sine squared theta. Great. Now, the only thing we're left with that has an x is this. And if I look over here, right, and I see the same thing, I can use cosine. If I use cosine of theta, cosine is the adjacent over the hypotenuse. So the adjacent is the square root of 25 minus x squared over the hypotenuse, which is 5. So if I isolate this, the square root element, I can multiply both sides by 5, and I get square root of 25 minus x squared is 5 cos theta. So, which I'll actually plug in right there. So I get 5 cos theta times 5 cos theta d theta over 25 sine squared theta. At this point, you can actually cancel out all the 5 times 5 is 25, right? 25 over 25 is just 1. So I end up with cos times cos is cos squared theta over sine squared theta d theta. Great. Now, what do we do here? My favorite thing to do in this point is actually to convert the cos squared into 1 minus sine squared. Because remember, the Pythagorean identity that tells us that sine squared theta plus cos squared theta is equal to 1. So if I decide to isolate cos squared theta, I get just 1 minus sine squared theta. And how does this help us? And I'm seriously running out of room here. I can split up this fraction into 1 over sine squared theta minus 1. And then at this point, I can go, okay, well, that's just the integral of cosecant squared, right? Because that's 1 over sine squared, minus the integral of just 1. Oh, whoops, I forgot the differential. Don't forget the differential. No. Okay. So now here at this point, what is the integral of cosecant squared of theta? That's just going to be the negative cotangent of theta. And the integral of 1 is just theta itself plus the constant term. Are we done at this point though? No, we're not. And why is that? Well, because we have everything in terms of theta, but we want the answer in terms of x. And I guess I'm going to try to fit the answer into this little box here. So, cotangent of theta. If I take theta, remember that the cotangent is going to be 1 over tangent. So, and 1 over tangent is going to be then adjacent over opposite. So the cotangent of theta will be negative square root of 25 minus x squared, which is the adjacent over the opposite, which is x, minus theta. And what is theta in terms of x? Oh, what a mess. This is turning out to be such a mess today. Well, sine theta is equal to x over 5, right? So it follows that theta is going to be just sine negative 1 of x over 5. Okay, because basically it's just an inverse function of sine that we can use to obtain that. So minus theta, which is sine negative 1 of x over 5, plus finally the constant term. And that's the final answer. So that's it.